Welcome to Finding Stuff Out. Today, you get 2 shows in 1. I'm practicing my magic act for my school's talent show. I'm trying to make my guinea pig squeakers vanish into thin air. So far, it's not working, but magic is all about changing stuff into other stuff, right? So maybe your questions about solids, liquids, and gases will help. Here's the first one from Victoria.
Why isn't magic real?
Magic is real! I just saw a magic man burn water! It started to smoke, and he said, if I don't buy a ticket to his next show, he's gonna burn down all our water! People used to think that anything they couldn't explain must be magic. Get me out of here! Like if you showed someone Finding Stuff Out who had never seen TV before, you could probably convince them that you shrunk me inside your magic box. Hey, yeah! Today, we know that magicians' tricks only look like magic. They all have logical, scientific explanations. Or do they? Is magic real? Maybe it is, and I just don't know how it works. But I promise to find out by the end of the show. Here's my second question. It's from Kevin.
Why does a balloon float?
Want to see me make this balloon disappear into thin air? But seriously, a balloon doesn't float. What makes it float is the helium. The balloon just goes along for the ride. I found out that the reason helium floats is because it's less dense than other gases in the air, like oxygen. But wait, how can a gas be dense? Doesn't that mean thick and heavy? But if the gases in the air are dense, why can't we see them? Why don't they crush us? My brain is steaming. It's going from a solid to a gas. That can only mean one thing. You're gonna make my head explode. Woo! I found out that dense just means something's tightly packed together, like when you take snow and smush it into a hard snowball. You've made the snow denser. But some things are naturally denser than others. This maple syrup is full of sugary goodness. Water is less dense, so it floats on top. That's sort of what happens with helium. Helium's lighter than most other gases, so it floats on top of them. Have you ever wondered if you could float through the air using helium balloons? Well, you could if you had enough. Let's see if I can make squeakers float. That's all the balloons I have, and they aren't enough. How many balloons would it take to get squeakers off the ground? Let's see. Squeakers weighs about 1,000 grams, and each balloon lifts about 14 grams. Wow, it would take 71 helium balloons just to lift squeakers. And a lot more for his cage. What? I made a guinea pig fly. To lift an average kid, you need about 2,500 balloons. Your parents probably aren't gonna buy you that many at an amusement park. But Kevin, people do float through the air using giant balloons. Only these ones don't use helium. I went to a balloon festival to find out how they float. I'm here with balloon expert Wild Bill. So, are these balloons the same as the helium ones that I get on my birthday?
No, not at all, Harrison. These here are all cloth-filled balloons. Just a big bag. All we do is we take the balloon and we fill it up with air. And then what we do is we superheat the air inside. Right. And then the balloon gets very, very light.
Oh, I found out that when you heat the air, it makes it less dense, which is why they're able to fly.
Exactly. You've got it. Somebody's been studying. That's good. 1, 2, 3, you. Dan, you on the handle? Come on down. You're on this side.
Okay.
I'm on this side, and we're going to bring this all the way back to where the basket is, all right? Keep going till you run out of balloon.
After unfolding the balloon,
here we go.
We fill it up with air using this giant fan. Then we turn on the heat with a gas burner. Bill has to make sure the flame doesn't get too close to the fabric, which can burn if it gets overheated. We're gonna go in, we're getting in soon.
Okay, Harrison, come on board, right in here, man.
This is crazy. And we're up. Oh. This is insane. This is so cool. So how exactly does the heat keep us up?
I constantly put heat in because the balloon is always cooling.
Right.
So if I want to maintain this altitude, I got to put heat in. I'm going to do that right now. So the balloon is now flying in level flight, and if we don't do anything, the balloon will start to cool and will start to descend. But if we let the balloon cool too much, then the balloon will come crashing to the ground too fast.
That's not good.
So we're going to control the amount of heat we put in so we can find a nice soft place up forward here to land.
Hey, Squeakers, how did you get up here? Look at them go. I never would have thought those balloons would have gotten you this high.
Squeakers, man, this is the only way to get around.
You funny guy. Bye.
How do you make water?
I am the water monster. I make water with my water monster magic. Just kidding. I found out that water is made up of two gases in the air, oxygen and hydrogen. Here's how they get together. Gas has a dance party, swinging through the air. Gas has a dance party, gases everywhere. Oxygen and hydrogen shake their derrieres, but if two H's bond with O, they turn to water. Down they go. When two H's bond to O, they turn to water. Look down below. So water's made by connecting an oxygen atom with two hydrogens. But if you're wondering how I, Harrison the Magnificent, make water, here's a cool trick. I told my sister I was going to drink mud. She got really grossed out, but she didn't know there was a way to get clean water out of mud. Want to see how the trick works? The experiment. This is called a distiller. I let my sister pour the mud into here and told her at the end of the week I drink whatever liquid came out. But will all the water evaporate before the week is up? Or will I have to drink mud? When the sun heats up the distiller, the water in the mud starts to evaporate. You can see the water vapor fogging up the sides. It's condensing. Then, when it cools off, the vapor turns back into water and drips down into the container. Whew, all the water in the mud evaporated, but the dirt didn't. It all got left behind. My sister will be so disappointed. That mud sure had a lot of water inside of it. You know what else has water? Us. 3/4 of a kid's body is water. That's why we need to drink a lot of it.
When you put water in the freezer in a jar, why does it break?
It happened to me once. I accidentally put a jar of pickles in the freezer. It broke and made a big mess. But to answer Keon's question without making a mess, it's time for... Uh-oh, do try this at home. Want to know a cool magic trick? Well, it's not really magic, it's science. But you don't have to tell anyone that. You take a plain, ordinary glass of drinking water and fill it all the way to the top. Then, tell your friends and family. Prepare to be amazed. I'm going to make this water get bigger. Presto, changeo, water, grow. Then, put it in the freezer. When the water is frozen, it will have grown taller than the top of the glass, all by itself. See? How did it do that? When a drop of water freezes, it spreads out to form an ice crystal. That's why a jar full of water breaks when you put it in the freezer. If the ice crystals can't go out the top, they break right through the glass. Remember that the next time you're putting away a jar of pickles.
When you put boiling hot water in a cup and then put it in the freezer and freeze it, can you make it solid, solid, solid?
To find out, please welcome my special guest, materials engineer, LV Dalgard.
Hey, Harrison.
Hey, I hope you have pickles in there. I like pickles.
Not exactly. If I had pickles in here, they'd be frozen pickles.
Oh. Maria wants to know if you can freeze boiling water and put it into really solid ice.
Sure, of course. You can change the phase of water no matter what temperature it starts at. In fact, if you're someplace really, really cold and you take a cup of coffee and throw it into the air, some of those droplets are going to freeze before they hit the ground.
Really?
And yeah, and the same thing happens with spit.
Cool.
Let's do a little experiment.
We're not going to be freezing spit around here, are we?
Don't worry. I want you to take these glasses and put them on.
Okay.
Because we're going to be dealing with liquid nitrogen, and liquid nitrogen is kind of like boiling oil. It'll burn your hand if you get it on your hand. So you're going to put the gloves on too.
It's so cold it burns.
Nitrogen, of course, is not dangerous in and of itself.
Okay.
So you don't have to worry about getting it in your food, which is good because this is cream and sugar, and we're going to make ice cream.
Wow.
And I'm going to start by pouring a little bit of the liquid nitrogen into the cream and sugar.
Whoa. I can't really see. There's so much fog. Seems to be getting like frozen.
Getting there, eh?
Oh, it's getting icy now. Can feel ice chunks in there.
Almost ready. Whew. All right, well, if it's too hard to stir, maybe it's ready to scoop some
Yeah,
out
it's hard
and taste it.
There we go. Bon appetit. Well, thank you for this scientific treat.
You're very welcome.
And here's another question. It's from Brianna.
Why doesn't ketchup come out of the bottle sometimes and it makes a big mess?
Well, the reason for that is that ketchup is what we call a non-Newtonian fluid. And in this case, that means that it gets thicker if you don't move it.
Right.
It gets thinner if you do move it.
So is there any scientific way to unstick it?
Sure.
Hey, that's not exactly scientific.
Actually, it is. See, the blockage is in the neck where it's thick. Remember I told you it was a non-Newtonian fluid?
Yeah.
And if you apply pressure to it, it thins out. Well, guess what? Thins out in the neck, comes right out of the bottle.
Non-Newtonian fluids. Those sound cool. Is there any magic tricks I can do with them?
Actually,
Really? That would be perfect for... My Great Challenge! Today, my challengers are Kobe, Haley, and Ashley, Zachary, Mateo, and Colton. So are you guys ready to do something amazing?
Yeah. Yep.
So if I told you you had to do some jumping jacks or jog for a couple of minutes, that sounds good, right?
Yeah. Okay. Yeah.
But what if I told you you had to do it on a liquid without sinking? So this is what you guys will be jumping on. It is made up of cornstarch and water. And let me show you something real quick. So if I am to punch it really fast, see, my hand does not sink, it's not wet. But if I slowly put it in, oh, gross. When I say go, the first person on each team has to jump into the pool. And you have a minute of exercises to do, and you have to stay on top of the liquid. When the minute is up, you'll be switching with your teammates. But if you sink before the minute is up, you will be eliminated. The next person in line has to jump into the pool right away and take their place. The last team with a person still standing wins. Okay, are you ready?
Yeah. Yep.
Go.
Oh. I can't. They're both down. Oh, no.
Okay, you guys are eliminated. Next person in.
This stuff is like quicksand. How can they jump on it?
I can't help.
The first two challengers are out of the game. Here are the next two.
Run and spot really fast.
Oh my goodness.
Hey, he has it.
Yeah. Oh, okay.
You're eliminated. Please switch with your teammate.
Yeah. Kobe, help out.
Okay, hurry, get in. Run fast, run faster. There we go.
Go, Kobe, go, Kobe.
Okay, now let's try some jumping jacks. How about just some straight jumping? Just do jumping, go. And switch, green team. Start doing some jumping jacks. Now let's try 1 foot. Oh, yellow team is eliminated. Green team won. Yeah. So did you guys think you could jump on a liquid? No? Well, I'm gonna let Elvie explain why you could.
Okay, well, the way it works is we call this cornstarch and water together a non-Newtonian fluid. It gets thicker or thinner if you change the stress, if you hit it.
So with ketchup, it gets thinner when we hit it. But with this, it gets thicker.
Think of it like you're trying to run into a crowd of people, right? If you run really fast, you're just gonna bang into them all. But if you go slowly and give them time to get out of your way, you'll be able to go through them. So it's the same thing with this. If you go really fast, you're just gonna bounce off it.
Well, thanks for playing my great challenge, and thank you, Elvie, for helping us find stuff out.
You're welcome.
Can a solid turn into a gas?
I checked the answer and... Whoa. Everyone, please welcome magician Ryan Lalonde to my show.
Hi, Harrison. Thanks for having me.
Welcome.
Happy to be here. Sorry, my hands are dry. Do you have any moisturizer with you?
I actually don't, sorry.
Okay, I guess I'll just use the moisture in the air.
How?
Well, here, I'll show you. My hand is empty. I'm gonna make a fist.
Okay.
And I'm just gonna grab the water, see?
What?
The water, and put it all in my hand, and you're gonna see.
How are you doing this? You must have something up your sleeve, right?
Not quite. A magician never tells his secret. Basically, what I did is I turned a gas into a liquid. Let me try something. I have a silk, which would be a solid.
Right.
I will put the solid into the glass. Now I have a white silk, which I can turn into white milk.
Is that one of those tricks where you make the audience look away and while they're not looking, you do something really fast?
Harrison, you're a tough audience.
There must be a scientific explanation. Dahlia was wondering, can you turn a solid into a gas?
I think you can. Let me try something.
Whoa, how'd you do that?
Well, it's very simple. I use what magicians call flash paper.
Right.
It has particles in the paper that are flammable and help the paper disintegrate.
Right. When paper burns, gases are formed.
Don't you burn yourself with that?
No, magicians have very safe ways of doing tricks. That's why kids should never copy the tricks they see on TV or in movies. I can show you something else about turning a solid into a gas.
Right.
Those are frozen blocks of carbon dioxide, also called dry ice.
Whoa, it's bubbling and there's smoke coming out of it everywhere.
So, Dahlia, the water warmed the solid carbon dioxide, and that made it turn into a gas.
Oh, and I just thought of another example.
A normal ice cube is solid, but when it melts, it turns into water. If that water gets hot enough, it turns into vapor. So water can be a solid, a liquid, or a gas, depending on the temperature.
What I have here is 2 glasses. A full glass of room temperature water and an empty glass. So we're gonna put this white piece of paper over the glass to make sure we know that this is the original empty glass. Now I'm gonna pour about half the water, maybe just a little more, into the glass. Now the purpose of this trick is to see if I can actually freeze the water in the glass. And you're gonna see that it is actually frozen.
Well, there must be a scientific explanation to that, too. Elvie already showed me how you can freeze things really fast.
I guess you just don't believe in magic.
Oh, that reminds me. I still have to answer Victoria's original question.
Why isn't magic real?
The big answer is... magic is real. Sort of. I can't wave a magic wand and make squeakers disappear. The tricks magicians do aren't real.
Hey, whoa, Harrison.
They're illusions, even if I can't explain how they're done. But the real world is pretty magical if you think about it. Think of all the stuff we saw that is real.
Gases turning into liquids, liquids turning into solids, solids turning into gas. Gases even lifted me into the air.
So even if I couldn't make Squeakers disappear... Squeakers? Where did he go? Squeakers? Squeakers?
Whoa, Harrison, did you check your hat?
Where? How'd you do that? I didn't see you do that.
Well, you're not supposed to. It's magic.
Hey, it's empty. What have you done with Squeakers now?
My name is Squeakers,
Hey!
and this is my show.
Squeakers? How did you get there? I can't believe this. See you next time for more Finding Stuff Out. Ryan, there has to be a scientific explanation to this.
Just ask me a question that I don't know. That's why Finding Stuff Out is the name of the show. My name is Squeakers, and this is my show. I'm finding stuff out that
Brr, it's chilly here. I've been thinking a lot about cold today. Because I saw a movie where scientists found a frozen caveman and brought him back to life. It made me wonder the same question as Justin. Is it possible to freeze myself and come back to life? Wouldn't that be cool? But it seems impossible. My frozen fish sticks aren't coming back to life, right? But I started checking, and I found something shocking. This frog was frozen solid in the winter. It was so frozen that if you were to move its legs, they would snap off. There's no way this frog could be still alive, right? But it was. When it thawed out, it was as good as new. What? That's impossible. They were frozen solid. That's almost as crazy as my fish stick coming back to life. What's all the excitement about? Some things that seem impossible are actually true. I found out that some frogs, bugs, and even turtles can survive being frozen. But I didn't find any big animals or people that can do that. So I don't know the answer yet to Justin's question. But I promise I'll find out by the end of the show. Maybe your questions about cold will help me. Why do you get a brain freeze when you drink something very cold? Well, Maya, I don't know if I can freeze my body, but I know I can freeze my brain. Ah! Maybe that was unwise. How do you do that?
Hey, chill out. I'll show you.
Cause you're pain near the top of your mouth, there's a tube to your brain. It takes blood right up to your brain. This tube is called an artery. It's really very smartery. When your mouth is too cold, it yells cold overload, pushing warm blood to your brain, and that's what causes pain. So don't you do it again. Now that you know, you should think me slowly. Yeah!
Is there such thing as the abominable snowman?
Well, Raphael, I know a girl who lives in the Arctic where there's a lot of snow. Let's ask her. Hi, Kylie. I'm just wondering, have you ever seen an abominable snowman?
Oh yeah, I've seen one before.
You have? What did it look like?
It was really big.
Whoa, when did you see it?
And Halloween?
Halloween?
Yeah.
Kylie tricked me. But some people really do think they've seen an abominable snowman. In the Himalayan mountains in Asia, they call it a yeti. A flat earth corner! I saw the abominable snowman with my own eyes. Buy a ticket to see for yourself. I'll guide you up the mountain if you dare. I even took a picture to prove it's real. Okay, so the picture doesn't do it justice. But for just $5, you can see the Yeti with your own eyes. The abominable snowman, or Yeti, whatever you call it, is just a myth. People who think they've seen it probably just saw bears. but I found another explanation. People in the mountains sometimes see shadowy figures and think it's the abominable snowman, but it's actually an optical illusion. When you're high up in the mountains and the sun's behind you, you can see your own shadow in the clouds. Ah! Ah! You're saying I was scared of my own shadow? Well, what about this footprints I saw? Huh? What do you say about that? I need an answer. Whoa! I've seen that same footprint right here in the attic. Just kidding. But some people have seen huge footprints in the mountains, like this one. I wonder if something else besides a yeti could have made them. Maxim and Kiana are going to help me find out. I printed out some other tracks that we do know. A grizzly bear's front and rear paws, a black bear track, a wolf track, and a human boot track. Let's see if our detectives can find a match and solve the mystery.
So that's a yeti paw.
I think we should try on some of the tracks on the yeti paw to see which one's the more similar.
Okay, let's try that one first.
The grizzly bear's front paw.
That kind of looks similar. There's still some differences.
Yeah, it's not long enough, though the front part seems to fit.
Let's try this one.
Okay.
The black bear paw.
No.
I don't think that fits.
What about the wolf paw? Nope. The human boot?
No.
None of those prints look exactly like the yeti print.
Maybe we should put this and put another bear paw just to make sure. It doesn't have to be perfect.
Smart. They're using both the front and the rear bear paw to make it fit.
Yeah, I think this is it. It's big enough.
It's right
I
there.
think it's good.
That makes sense. If a bear makes a print with his front paws, then steps just behind it with his back paws, the combination looks like a giant footprint. That's probably what fools people. Thanks, detectives. So, to answer the question...
Is there such thing as the abominable snowman?
Well, from what I can see, there's no proof it exists. Aww. Psst. Hey, Zoe. You're ruining my ticket business. Don't you have another question to answer? Come on.
Do Inuit really live in igloos?
I checked, and Inuit now live in modern houses. They also use modern snowmobiles to get around. But the Inuit invented all kinds of things that made life possible in the far north. The Inuit invented snow boots.
These are gummits, and they help keep our feet warm, and they help us keep up on the snow instead of sinking.
Here's something else.
Did you know that Inuit invented the kayak?
That's right. The Inuit invented the kayak, a kind of boat that can travel through icy water. They also invented goggles. And they even invented dog sleds, which were the fastest and furriest way to get around the Arctic before snowmobiles. But the igloo was the Inuits' most famous invention. Outside temperatures can get as low as minus 45 degrees Celsius. But inside an igloo, it can warm up to 16 degrees Celsius with just our body heat. Ah, it's so cold! I want to be in an igloo! An igloo is a smart way to stay warm. I think I'm gonna ask my friends how they stay warm.
Ask a friend. I would make a pile of snow, and then I would make a kind of like a dent inside, and I would probably lay in it.
I put many layers of clothes. First I put tights, then I put my normal pants. Then I put a third layer of splash pants.
I would keep my body active so I keep warm. Bring a bowl of soup with me outside and eat it because soup is hot so it could warm you up. Put on a jacket, like 4 sweaters. I would go inside my house.
Those are all great ideas, but I think you need some expert help.
It's too late!
No, it isn't.
She works in the Arctic where it's cold and Arctic, and the seals like to Barctic. Please welcome Fantastarctic, Marianne Bernardo.
Hi, Zoe.
Hi, I didn't know you were bringing a friend. Nice to... Where's his hand? So, do you really work in the North Pole?
Yeah, I do research in the Arctic to understand how climate is changing the ways animals and people live and get food in the extreme north.
What's the coldest you've ever been?
I think it was about minus 30 degrees, but it was very, very windy. That's why I wear a special suit that's even warmer than a regular coat. It can go about at minus 40 degrees, I think.
Yeah, it's really thick. It must be warm.
Oh yeah, it's really warm. It has a lot of insulation, which means that it keeps the warmth of your body inside the coat and keeps the cold air outside.
Yeah, I definitely want to wear one of these if I was in the coldest place. But here's a question from Chelsea.
How do animals stay warm in winter?
Yeah, what do animals do in the cold? They can't just buy a coat.
I wonder if it comes in pink.
I checked, and some animals obviously have built-in fur coats, and sheep have wool coats in the winter. In the summer, ranchers shave off the wool so the sheep don't get too hot. We use the wool to make sweaters and blankets to keep us warm.
Woohoo! Win-win.
Birds keep warm with their feathers and fuzzy stuff called down, which we sometimes use to make comforters and jackets. But I noticed something about animals who live in really cold places.
Yeah, what's that?
They have a lot of fat on them. Does fat have something to do with staying warm?
Yes, warm-blooded animals have to keep their bodies at a constant temperature. So many Arctic animals have what's called blubber, a kind of fat that insulates their core. It's sort of like what my cold weather suit does.
I've worn a wool coat and a down coat, but I've never worn a blubber coat. That gives me an idea for... my great challenge! My challengers today are Ruby. Hi. And Jaden. Hi. Are you ready for a very icy challenge?
Yeah.
Yeah, I'm ready. Okay, imagine you're seals in the Arctic. And you're trying to catch fish in icy water. It's so cold, I can barely put my hand in it. Your challenge is to reach into the icy water and grab as many fish as you can in 60 seconds. But don't worry, you're seals, so you have a blubber coat. Marianne will show you how.
So first, you have to dip your forearm into this tub of shortening.
The shortening acts like the seal's blubber. Pretty squishy, huh?
So weird. It feels so, like, slimy.
And now, just like seals, you need some skin to hold that blubber together. So let me help you put that on.
That glove's also full of blubber.
There you go.
This is so weird. Whoa.
Okay. Now the skin.
Is it slimy?
Yeah.
Okay, time to go diving in the icy water. Remember, the one who gets the most fish wins. On your mark, get set, fish it!
There's one. Come on.
Go! Find them!
That's ice. One. There's another one.
Only 12 seconds left, and it's tied up at 3-all. 4-3 for Ruby.
One more.
Jaden ties it up with 5 seconds left. Ruby gets one. Jaden reaching for a fish. Okay, time's up. Jaden, you have 1, 2, 3, and 4. Ruby, you have 1, 2, 3, 4, 5. Okay, so Ruby, you're the winner. Woo! Okay, so I want you both to put your other hand in and tell me the difference.
Okay.
Oh,
that's way colder.
Yeah, that's because on the right hand, you have the blubber like a seal.
Yep.
And on the left hand, you're a human.
Right.
Okay, because you guys were such great seals, your reward is you get to keep the fish. Ryan had a question about animals without blubber.
How do fish live under the ice? It must be cold there.
Yeah, good question. Fish don't have blubber. How can they not freeze under the ice?
In the cold, fish can slow down their body's functions, so they use less energy.
That's like a video I saw about frogs and how they freeze.
Yes, frogs can do that because they are well adapted to their environment. So are Arctic animals. We've learned about marine mammals that have a thick layer of blubber so that they can live in the Arctic. And then Arctic fish can survive in extremely cold temperatures.
Oh, so could we humans slow our bodies down? Could I freeze myself in the winter and come back later like a frog?
No, humans aren't adapted to do that. You know how you shiver when you're cold? It's your body working hard to try to stay warm. In really cold places, your body tries to keep its core warm, and then your fingers and toes are extra vulnerable to frostbite. We could die in extreme cold.
It's not looking good for Justin's question about how we can freeze ourselves and come back in the future. But I'll keep checking. Thanks for helping me find stuff out, Marianne.
My pleasure.
Marianne said we can't freeze ourselves in the snow and thaw again like frogs. But what if we had a super techno freezing machine? Let's find out. Hi, Don.
Hi, Zoe.
I'm here to see your high-tech freezing machine.
Okay, but we're gonna have to get dressed up first.
Okay.
Let's go.
I'm at the National Research Council's climate chamber, where they can make it as cold as Antarctica. Wow, it was so hot outside, but it's so cold in here.
This is our climate chamber.
It's basically like a giant refrigerator. What do you use it for?
Oh, we use it for all kinds of things. We test trucks and trains and tents to keep people warm in the winter. Anything that's outside, we can test it inside.
Cool.
Very cool.
Woo! It's winter again! Woo! Whoops! Sorry, having too much fun. But here's a question from Dario.
Is the South Pole colder than my freezer?
Oh, the South Pole is much colder than your freezer. It can get as low as minus 89 degrees C at the South Pole. Your freezer's probably only minus 20, so it's very much colder at the South Pole.
Well, I guess at the South Pole, a freezer would be a good place to warm up. On weather reports, I see something called the wind chill. What does that mean?
When the wind is blowing, it takes heat away from your body, so it makes it feel much colder than the real temperature.
How big a difference is it?
We could find out if you like. We have a big fan.
I think you mean a ginormous fan. It was so cold in here before, but now it's even colder. It feels even colder.
It does.
I don't think I've ever felt colder cold than that.
That felt like minus 65 degrees C. It was only really minus 30 degrees C, so that's 35 degrees colder with the wind.
It was like we really were at the South Pole. I could really use a hot chocolate now. Hey, what would happen if you took hot chocolate and put it in the climate chamber? Would it turn into instant ice cream? Some of my friends did an experiment like that. They live in Nunavut, where it's seriously cold in the winter.
2, 3, throw.
Whoa! So cold that if you throw hot water, it freezes before it hits the ground. Pretty cool, huh? Think we can try something like that?
Let's go try it. Ready, set.
Wow! The water froze in mid-air.
That's pretty cool, isn't it?
That is pretty cool. That was awesome. Being a scientist looks like a really cool job. But now, let's answer Michael's question about freezing stuff.
How cold would it have to be to freeze a ball of iron all the way through so that when you drop it, it shatters?
Okay, so gummy bears aren't exactly iron, but we're gonna see what happens when they get frozen solid.
First, let's see what happens when we hit one that's at room temperature.
It just got squishier.
It's just a little bit dented.
I wonder if the frozen one will be different.
Let's try it.
Yup, that one's frozen solid. It shattered into a million pieces.
So, when the gummy gets really cold, it turns almost into glass. The molecules stick together just like the molecules in glass. So when we hit it, it breaks just like glass.
Interesting. But could you freeze an iron ball so cold that it shatters?
You could, but it'd be pretty hard. Iron balls are made to be strong.
Uh-oh, do try this at home. Want to see for yourself how cold changes things? Take 2 identical rubber balls, or tennis balls. Put one in the freezer, one someplace warm. The next day, see how differently they bounce. Check this out. The frozen one hardly bounces at all. Let's see that again in slow motion. Exact same kind of tennis ball, but when it's frozen, it loses its bounce.
But what would happen if people were frozen solid? Have you ever tested that?
That would be a very bad idea. We don't have the technology for that just yet. The water in their cells would freeze. That would kill them.
Yikes. Well, thanks for helping me find stuff out.
You're welcome.
And that takes us back to Justin's question that warmed up my show.
Is it possible to freeze myself and come back to life?
The big answer is... no. We can't freeze ourselves for the future just yet. We die from just being frozen. But maybe that's why people have invented ways to stay warm and survive in the cold.
We invented clothing that keeps us warm in extreme cold. The Inuit invented igloo shelters and ways to get around in cold places. We learned to build big buildings that protect us from winter weather. We even have climate chambers to test how our cars and machines will work in the cold.
We humans are pretty smart. Cold may be dangerous for us, but we've invented all sorts of ways to outsmart it.
I shall defeat you.
Okay, maybe some things the human mind just can't solve yet. Ow. Oh, see you next time for more finding stuff out. My dad and I were just trying to make cookies, and this happened. I was just trying to cook up an answer for Audrey.
Why does heat cook food?
It's pretty amazing if you think about it. If you add flour, eggs, sugar, butter, and some other stuff, and you put a little heat in it, you get this. But if you heat it a little bit too much, you get this. How does heat do that? Maybe your questions about hot stuff will help me answer. Blech! Yeah, this is definitely burnt. Speaking of which, here's a burning question.
Why does some stuff melt and some stuff just burn when you heat it?
Well, Tristan, to answer that, knows all about hot, so ready or not. Here's my special guest, Shakib Rahman.
Hey, Zoe.
Hey.
I'm all fired up to be here to help you answer some questions about why some things melt and other things burn.
Is that why you brought the biggest chocolate bar ever? Are we gonna eat it? Please tell me we're gonna eat it.
Oh, we're definitely gonna eat it.
Wait, did he say eat or heat? Ice water? I thought we were supposed to be making stuff hot.
Well, when we're talking about hot stuff, it's important to remember that heat flows from something that's hot to something that's cold. Like this pitcher of ice water.
Oh, I get it. Heat flows from something hot like my hand to something cold like this ice water.
Yeah.
Let's eat. Eat the chocolate.
Do you see what's happening, Zoe?
Yeah, it's melting.
Yeah, it's slowly starting to become a liquid.
Why?
It's because the energy from the water is getting transferred into the chocolate. Just like when you put your hand on the cold pitcher of water, the heat from your hand went into the ice water. Here, the heat from the water is going into the chocolate.
Cool. Hot.
Exactly.
Oh, it's melted. Does everything melt at the same temperature?
That's a great question. But everything doesn't really melt at the same temperature. The chocolate has melted, but the glass bowl that it's in is still a solid. Same thing with the spoon that I've got in my hand here. That's still a solid as well.
Anything will melt if you heat it enough?
Well, here's where it gets weird. Some things don't really melt when you heat them. They just burn. I've got a little wooden splint here.
Fire!
Exactly. Some things will burn, and this is called a combustion reaction, when it burns instead of melting.
By the way, don't try this at home.
Some substances will do both. Cheese is a good example of this. First it'll melt, and then it will
burn. And sometimes it feels like we're the one melting and burning. Neve had a question about that.
When it's sunny outside, why does the sand burn your feet?
Oh, it's a sunny day. I just want to play in my bare feet, in my bare feet. But oh my gosh, the sand is hot. I can't stand still, it hurts a lot. It's the sun's heat, it's burning my feet. The sun has heated up the sand, and now it's more than I can stand. It's heating my feet, it's heating my feet. Yeah, yeah, yeah! Hot! Ow! Yikes, this is really hot! Ow! Hot!
Beach sand can get really hot. But if you keep heating sand all the way up to 1,700 Celsius, hotter than lava, something amazing happens. It melts and turns into a thick liquid, like taffy. And when it cools down again, it hardens and becomes glass. But heat can also be used for destruction! Camus, we have the same question.
How does heat make something explode?
Yeah, how come stuff blows up sometimes when you heat it? Shakib did a cool experiment with Jenna and Marco.
The experiment!
Hey Zoe, we're out here trying to do our first experiment. Do you guys know how to make an explosion?
Yeah, take some fuel and light it, and it'll cause fire to make the explosion.
That's perfect. You guys know any examples of fuel that we could use?
Like gasoline?
Yeah, gasoline is a great fuel. It's actually a fuel that we use when we're creating explosions every day. Out here in the parking lot, we're surrounded by things that actually cause explosions all the time. The engine of your car has something called an internal combustion engine. And those cars cause explosions, and that explosion can do work for us. We're going to do the same thing here. Now remember kids, this is a very dangerous experiment. Please do not try this at home unless you are supervised by a professional like me. What we're going to do is take this tennis ball and launch it out of this cannon. I need you guys to take 3 large steps backwards. Good. Now what I'll do is add the fuel in. The next thing we need to do is put the tennis ball inside our cannon. Once we ignite the fuel inside the cannon, it's going to force the tennis ball to come out the end and hit that target over there.
3, 2, 1.
Oh, that was amazing.
That was so cool. We use explosions for big stuff, like demolishing buildings or blasting tunnels. But if you can control explosions so only a little energy is released at a time, you can use them to make things move. Shakib has another experiment. It's called Gummy Bear Meltdown. Shakib, take it away.
First, take the special chemical that I've prepared and, very carefully, pour it into my test tube. The next thing I need to do is add some heat, and for that, I use a propane torch. This is very dangerous, so don't try these experiments at home. Once it's all melted, we can add in our last ingredient. Any last words, my fine gummied friend?
Wow. Who knew gummy bears were explosive? I'm glad they don't explode inside of me.
Well, they kind of do, actually.
What?
What happens is the energy from the gummy bear gets broken down in your body, specifically in your stomach. From there, that energy, all of the sugar in our gummy bears, gets used up to power your muscles and your body to help it move around.
Speaking of gummy bears, I got a sweet question from Amanda.
When you heat sugar, how does it turn into candy?
To find the answer, I went to meet candy maker Ling Gang.
He makes special hard candies by hand, and they have little images and messages inside. There's little panda bears inside. How do you do that?
It's all about controlling heat. Come on, I'll show you. Today, we're gonna make some special candies that has your show logo in it.
Oh, the magnifying glass of my show. Awesome.
First, we have to mix the ingredients for the candy. Take the water, pour it into the pot. Now, pour these 2 bowls of sugar.
That's a lot of sugar.
No, the sugar glucose.
It's really goopy.
Now we have to heat the ingredients. The mixture has to reach a very specific temperature, just right, to make the perfect candy.
What temperature is just right?
I can't tell you the exact temperature because that's the secret recipe.
Oh, please?
No.
Come on, tell me. Tell me the secret. Come on.
Can't tell you.
I won't tell anyone.
Sorry.
Oh, come on, just tell me.
It's a secret. But I can show you a test we do that tells you whether the sugar is ready.
Okay, that works.
We drop the mixture into cold water to see what it does. So now you can try to touch the sugar to feel its texture.
Oh, it's really soft.
This is called the softball stage. When it's soft like that, it's not hot enough for what we need. So we have to put it back on heating.
After a few more minutes of boiling the sugar solution, let's see what we get. Oh, hey, it's hard.
Yeah, this is the hard crack stage. You see how it bends and breaks? This is perfect for what we need.
That's amazing. Just a little change in the temperature made the sugar way different.
Now we can make our little candies with it.
Cool. First, it's time to add color. The red sugar will be the handle of the magnifying glass.
And the orange is going to be the circle around the glass. And this is the white background. We're going to turn this pile of yellowish goo into a snow white color by stretching it on a hook. This process adds air into the candy.
That's hard work.
Pull, 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 pull. Yes. Is it hot?
Hard to pull it.
Yeah, now it's cooling off faster and faster. See how white it turned out?
Yeah. Now that all the candy stuff is made, it's time to put the pieces together. Lin Jen uses a special heated tabletop to keep the candy soft enough to work with. Wow, so much depends on everything being exactly the right temperature.
Exactly. That way we can control the shape. The heat is our friend.
This is where Lin Jen does his magic. He puts together all the pieces that make up my show logo, then wraps them all up in white and orange candy. Look at that. By using heat, Lin Jen is able to take a huge candy chunk and make it thinner and thinner. Amazing. These are so good. Thanks for showing me how heat can make sugar so much fun and delicious.
You're welcome.
This next super hot question is from Maya.
Why is it getting warmer in the Arctic?
It turns out heat doesn't just make stuff explode, melt, and expand. It can change something much, much bigger. Bigger than my house. Bigger than my town. Bigger than a whole continent. Bigger than the entire planet. You're gonna make my head explode! Ah! Yay! My next guest knows all about it. Thomas Ribeiro won first prize at a national science fair with a project to make electricity while getting rid of something called greenhouse gases. So what are greenhouse gases?
Well, greenhouse gases are gases that can be found in the atmosphere, and they could be produced both naturally or by human activities.
Thomas tells me that when we burn fossil fuels like oil and gas for energy, greenhouse gases are released into the air. Garbage dumps and burping cows make even more of them. Because they float high up in the atmosphere and trap the sun's heat around the Earth like a warm blanket, greenhouse gases are changing our planet, causing floods, fires, and weird weather. Phew! How do the gases trap the heat?
Let me show you. These jars actually represent the Earth. Let's pour some water in both of the containers, seal them up, and zip a plastic bag around one of them shut. This plastic bag is representative of the greenhouse gases that surround our planet in the atmosphere. Now, we place it under a sunny place or bright light for about 2 hours.
So now we wait.
Now that 2 hours have passed, let's take the temperature of the water in both the jars.
Whoa, it's warm.
Right, the plastic bag trapped the heat as the water was warming up. And the second jar represents the Earth without such a great quantity of greenhouse gases in the atmosphere. Let's measure the difference of temperature. (44.3 degrees Celsius). And what about the second one? 46 degrees Celsius. That's a 2 degrees Celsius difference.
That's a small difference.
Right, but a small difference can make a huge impact on our planet.
And that, Maya, is why the ice is melting in the Arctic. Thanks for telling us all about it.
No problem.
Speaking of hot stuff,
where does fire come from?
the Flat Earth Corner! Beware, such a ruler of fire giants. Scourge of men and earth is coming to set the entire world on fire. He will wield his massive flaming sword, and no one will be spared. No one! So get yourself a fireproof vest and a rowboat and run for your life! Ah! We're all gonna die! Pretty much every ancient culture, from the Vikings to the Egyptians, believed in some kind of fire god or goddess. But now we know a lot more about fire and where it comes from. So I think I found the answer to your question. In nature, fires start from lightning or from hot lava spewing from volcanoes. We humans can make fire with a match or lighter, by banging special rocks together, by mixing chemicals to cause an explosion, and sparking something with electricity. Noah has a question about another way to make heat.
Why do your hands get warm when you rub them together?
Oh yeah, friction.
Ow!
Friction happens when one object rubs against another. They heat up. That gives me an idea for... my great challenge! Veronica and Kiana, your team sleeve. Chloe and Daniela, your team toque. Yeah! Today we're heating things up with friction. Shakib over here has a thermal camera, which can actually see heat. Cool! I think they mean hot. So your first challenge is you have 10 seconds to make as much heat as you can by rubbing your hands together. Kiana, you will start first.
10, 9,
Shakib will measure the heat that your hands transfer to this board.
5,
Push harder!
4, 3, 2, 1. 26.2.
Pretty good. Okay, Chloe, your turn.
10, 9, 8,
Faster!
7, 6,
Push him.
5, 4, 3,
Faster.
2, 1. Put
Go.
your hands down. 30.7.
Okay, Chloe, you win. Yeah! 1 point for Team Toque.
10,
Second challenge, rubbing sandpaper on wood.
7, 6, 5,
Push harder.
4, 3, 2, 1. 41.
Wow. Daniela, your turn.
10, 9, 8,
Faster.
7,
Come on,
6,
push harder.
5.
Look at that. In only 10 seconds, the piece of wood's room temperature is rising from 20 degrees to...
41 also.
So I guess both of you get a point. Yeah!
10, 9,
Third and
8,
final challenge,
7,
a pedal to the metal
6,
friction challenge. Friction
9,
makes so much heat
8,
that it can make a race car's
7,
tire melt right off.
That's why cars need to put new ones on during a race.
3, 2, 1. 27.7.
Pretty good. Okay, Danielle, your turn.
10, 9,
Go, 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 go.
8, 7,
Faster, faster.
6.
It's 2-1. Will it be a tie or will Team 2 win? They need to beat 27.7 degrees.
28.2.
That means Team 2, you win the challenge! Yeah! Thanks everybody for being on my show and helping me find stuff out about heat.
Yeah, that was hot. That's hot. Why do we eat hot food?
Good question. Why do we eat hot food? I found out that in prehistoric times, we humans ate our food raw until we figured out how to cook it over a fire. Eating food actually changes it, so it's easier to chew and swallow. Look how different the meat is before and after it's cooked. Cooking food also kills germs called bacteria, which makes it safe to eat. And some foods like chicken should never be eaten raw because it has bacteria that can make you really sick. Ugh, I would never, ever eat a raw chicken. Ask a friend. Hey guys, what food do you think tastes better cooked than raw?
I think carrots and potatoes and meat. Meatballs.
I like cake better when it's cooked. Noodles.
Fish. Cookie dough, because when it's like raw, it doesn't really taste good, and if you eat it raw, it like hurts your stomach.
I love frozen pizza. It's the best.
So I found out today that heat can do incredible things. It can make stuff expand, or melt, or boil into a gas, or change it to something else, or even explode. I think I'm ready to answer the question that started my show.
Why does heat cook food?
The big answer is... it transforms our ingredients into something completely different. I found out that adding heat to food causes a chemical reaction. Heat breaks the ingredients down into a mixture of chemicals that feel good in your mouth and taste awesome. Unless you heat them too much, then they taste less awesome. Hey, I can put the candies inside of the cookies. Hey, Dad, get out your mixing bowl. I just had the greatest idea ever.
Hi, welcome to Finding Stuff Out, where I answer your big questions. Like, what is all this stuff? Stick around and you'll find out, because by the end of the show, I promise there'll be an explosive finish. Now, I always start the show with one of your questions, so here's the first one.
What will happen if someone cracks the Earth?
The short answer is mass destruction, disaster, chaos, the release of giant radioactive monsters. But seriously, if there are underground monsters waiting to escape, I want to know about them. So by the end of today's show, I'll find out what would happen if someone cracked the Earth. Here's a question from Jaden.
What I want to know is, how does an earthquake happen?
Well, there isn't an earthquake happening here at the moment, but I do know where to find out about them. My good friend and roving reporter Sydney is at the Science Center.
North Sydney Report.
Thanks, Harrison. Today I'm with Julie Jones, the earthquake expert. How does an earthquake happen?
That's a great question. The Earth is a bit like an orange. Inside the orange is liquidy and juicy. Inside the Earth is liquid rock. It's hot. Now, on the outside of the Earth, there's a crust. Just like on the outside of the orange, we have a peel. But they're in plates. And so I've kind of shown here that we've taken the orange open, and when those plates shift and move, that's when we get earthquakes.
Julie told me that where tectonic plates meet, that's where earthquakes and volcanoes happen. Like here, around the edge of the Pacific Ocean. There are so many earthquakes and volcanoes there that that it's called the Ring of Fire. This map shows the number of earthquakes that have happened in the last 30 days. Wow, there's a lot. Julie tells me they use something called the Richter scale to measure their energy.
The actual scale ranges from 0 to 10. Now, we've never had a 10. That's incredibly a massive earthquake. But anything less than a 2, we don't really notice at all. Something from like a 2 to a 3.5 or a 4, you're going to notice the earth, it's going to move a little bit. Maybe some of the china in your cabinet that's a little close together is going to rattle. You might see some liquid moving in a fishbowl. But it's still a fairly small earthquake. But once you get into the 4s and the 5s and the 6s, then the building starts to shake. And once a building starts to shake, there can be damage in a building. And once you get up to something that's a magnitude 9, well, those are some of the biggest earthquakes we've ever had, and those are incredible. The whole building just wobbles back and forth. They collapse. We have tsunamis. All of those things go with a 9. All right, so when the surface of the earth moves, the buildings move. And we try and make our buildings safe by building them using certain techniques. Here we have 2 distinct buildings. One is a very standard building, the other one is actually on a base that shifts back and forth, so that when the earth shifts, in theory, it doesn't move around as much, making it a safer building to be in. You've got some handles that give the table a shake.
Oh, I see. So this one moves with the earth, whereas this one just shakes back and forth.
Yeah. Now, we just discovered that this building will be the safer building to be in, so clearly it will survive a stronger earthquake than this one.
I also read that diagonal crossways for a building would make it more stable. Does that mean that if I were building out of Lego or Connects, if I made my base of my house with diagonal crossed bars, that would make it stronger than just straight?
Yes, if you're working in Connects, triangle shapes are the strongest shapes. So if you incorporate those with like a diagonal to an X across a square, that's going to be a stronger building.
But what about something like a road? What would happen to a road?
The plates go over top. So when it shifts, the road goes up, the surface goes up. Now this is a big earthquake. So Sydney, you had asked me about the Richter scale and how we measure earthquakes. This is a seismometer. Let's give it a demo. Why don't you give us a stomp, make the earth shake if you can, and we'll see how it measures up. Not too bad. It's a little.
I made a blip.
You made a blip. So you can imagine the more you've shifted the earth, the greater the energy, the higher the magnitude.
Oh no! What have I done? Whoa! Sorry about that, Harrison. Hang on!
Just kidding. But imagine if tectonic plates had to explain to their mom who made this big mess.
It's not my fault the earth went crack. He pushed me, so I pushed him back. It's not my fault this seismic rift. Pacific plate, he started it. When plate pushes plate, you get an earthquake. When plate pushes plate, you get an earthquake.
Now here's a question from Rianne.
How can they predict the weather, but they can't predict earthquakes?
Actually, Rianne, even weather forecasts are only accurate 7 times out of 10. There are so many forces involved in creating an earthquake that scientists still haven't figured out how to predict them yet.
Uh-oh. Do try this at home. If you're in an earthquake, you have to get away from anything that might fall on you. Even on a desert island.
So what if the earth started shaking right now, like this? You feel that? It's a tremor. Where do you go? What do you do? So the best place to be during an earthquake is outside, away from buildings, trees, and power lines. But, of course, you can't predict where you're going to be when there's an earthquake. So during an earthquake, it's best to be under a sturdy table like this because it protects you from anything that falls. Another great place is to sit under a door frame because the frame protects you from things that fall. Whew. but you're not really likely to feel one unless you live near a fault line.
This is a picture of the San Andreas Fault in California, where the Pacific Plate meets the North American Plate. The movement of the plates is slowly pulling California apart. Eventually, Los Angeles will slide past San Francisco in about 20 million years.
So while we're waiting for that to happen, let's take a question from Atom, who wants to find out.
How does lava get created inside volcanoes?
The Flat Earth Corner! So how does lava get created inside volcanoes? Well, here in ancient Rome, we've got that figured out. The god Vulcan has a blacksmith's forge in there. And volcano, get it? It's so funny because I made a joke and it was a funny one. Silly Romans, I am René Descartes. Here in the Renaissance, we admire the Romans, but instead of superstition, we have science. Through observation and deductive reasoning, I have concluded that volcanoes are created by the sun burning holes into the earth and allowing lava to escape. Makes sense, no? Descartes was a mathematical genius, but his explanation about volcanoes didn't make any more sense than the Romans. To find out how lava is created, please welcome a real volcanologist, Professor John Sticks. Hi.
How you doing, Harrison?
Welcome to my show.
Thanks for having me.
So can you tell me how lava is created?
This little can is going to tell us something about how volcanoes work.
A can of mixed nuts?
Yep.
I think I know what's coming, but I'll bite. Are you saying that snakes make lava?
Well, not exactly, wise guy.
The experiment!
How is a snake like lava?
Okay, so that's a good experiment that shows that when pressure is released, a volcanic eruption happens. What happens is the magma breaks, then you get lava.
Magma is the melted rock and metal under the Earth's crust. It turns into lava once it reaches the surface of the Earth, like when it comes out of a volcano.
So what do you have here?
It's a can of soda. We'll pop this one open slowly, and we'll fill up this baby bottle. Okay, soda pop is actually a great analog for a volcanic eruption and a volcano, because what's happening is that you're releasing pressure, and when the pressure is released, bubbles come out.
Oh, whoa, it's filling up.
So that's exactly what happened there. The bubbles came out,
air?
And the pressure built up in the volcano. This is our volcano.
So now it's time for another question.
What would happen if volcanoes were everywhere?
Yeah, what would happen? Would it be like my scene of destruction earlier?
Yeah, it would be a mess, but it actually doesn't work like that. Most volcanoes are actually not erupting right now. They're fairly quiet.
Oh, okay.
And some volcanoes, after a few months or a few years, start to get active, and they go into eruption, and they might erupt for a few months or years, but then they quiet down. There are a couple of volcanoes that are always erupting, but these are pretty small volcanoes.
Oh, okay.
Yeah.
Well, then let's take another question. This one's from Melissa.
Does lava turn into a special rock when it hardens?
Okay, so think about lava. We see pictures of lava flowing in places like Hawaii, for example. Yeah. Okay, so it can come out as lava, but it can come out as ash too during an explosive eruption. So here is one volcanic rock. You can hold that.
It's like it was like polished, sort of.
Yeah, it's actually glass. It's called obsidian, and it has cooled really, really fast, just like glass does.
That's really cool.
Let's look at another one. Okay, so here's a piece of pumice.
Yes, I've heard of this.
Yeah, okay. So pumice is material that's been erupted out of the volcano, but the reason it's so light is that it's full of gas bubbles from all the gas, just like our can, okay? Same idea, full of gas bubbles that came out of the magma as it was erupted. Do you think this is heavy?
Probably.
It's not actually that heavy.
No, you're just gonna show
it. Okay, yeah. So inside this rock, this is a great rock. So this is called a volcanic bomb. And inside the rock, it's full of bubbles, okay? And on the outside, it cooled faster than inside.
Really?
So it's full of cracks. See, all these are the cracks?
Oh yeah, all these things.
Yeah, and then inside here, if we dropped it, which I'm not going to do, if we dropped it, we would see tons of bubbles. It would look something like
that inside?
Yep.
It would split open, yeah. Okay.
Let's do one more thing, okay? So let's think about magma flowing in a conduit before it erupts, okay? Flowing through the throat of the volcano. So here's the magma right here. It's actually sort of silly putty. So what we're gonna do is we're gonna make the magma flow slowly first.
Okay,
so just pull slowly.
Okay.
Okay, here's slowly flowing magma. Okay, no problem. Lava comes out and so forth. Okay, perfect.
Okay.
So now, all of a sudden, for some reason, maybe because there's a lot of gas in the system, the stuff, instead of flowing slowly, it's flowing fast. 1, 2, 3. Okay? So it didn't flow. It didn't flow. It actually broke. So it can come out as big pieces, one big piece, one big piece, one very big piece. But it can also come out as ash. So these are very small pieces.
So that's how you get all these cool shapes I found.
Okay, so this is a picture of the Giant's Causeway in Northern Ireland, and it's showing a series of lava flows. And the columns, they're actually called columnar joints, and it's caused by the cooling of the lava. This other picture is a picture of the Hawaiian Islands. I think it's a very great place to look for lava flows. You can see wonderful lava flows actually in the process of forming and flowing and actually flowing into the ocean sometimes. Yeah, and this is an example of a lava tube. And a lava tube is basically just as it sounds, lava flowing through a tube. And one reason it's able to flow in the tube is because the tube insulates the lava, so it stays hot, it's able to flow, and it's actually able to flow sometimes very long distances.
Okay, so now what are we doing over here?
Okay, we're going to look at 2 pieces of volcanic rock.
Okay, so
pick up the first one.
This one.
So people actually use that for their barbecues?
It has a bunch of holes.
Yeah, throw it in the water now.
Okay.
Okay, so that sinks.
It just sank right
Most
away.
volcanic rocks sink.
Yeah.
Throw that one in the water.
Okay, so this one, it floats.
It's got so many bubbles, it's super light, less dense than water, so it actually floats. And this is from a highly explosive volcanic eruption.
So maybe it's the only rock that floats?
Yeah, I think it is the only rock that floats. That's exactly right.
So thanks for helping me find stuff out. Can you come back later for the big finale?
I wouldn't miss it.
Awesome. Amazing, isn't it? Volcanoes make you think of destruction and ruin, but there are a lot of positive things that come out of them too, like soap.
Besides that, volcano stuff is also made into blades that eye doctors use to perform delicate surgery. It's in the cement used to build our homes and schools, and in fertilizers that help to grow our food.
Let's take another question. This one's from Sam.
My question is, what's the temperature inside of a volcano?
The temperature inside of a volcano? Okay, let's take a look. The temperature inside of my house is about 20 degrees. And we know a volcano is hotter than that. Water boils at 100 degrees Celsius, but rock melts much hotter than that. Our oven can bake stuff at 220 degrees, but I don't think rock can melt in it. Maybe if we use 16 ovens, 220 times 16, probably close to the temperature of my brain right now, which is hot enough to...
You're gonna make my head explode!
So I'm gonna go out on a limb here and say that the inside of a volcano is really hot. But to get a more precise answer, I'm gonna go over to Sydney at the Science Center. Over to you, Sydney.
Thank you, Harrison. Now we're gonna meet George Karunas. Speaking of which, where is he? What is that?
Hi, Sydney.
How are you?
I'm pretty good. Getting kind of warm in here.
What is this?
This is my volcano heat suit. It's a specially designed suit that allows me to not only get close to volcanoes, but right up to the lava.
So you've been into real volcanoes with this?
Several times, yeah. It's what I do.
That is so cool.
I explore erupting volcanoes.
It must have been really hot, though.
Exactly, and that's why I wear the suit. Lava can be 2,000 degrees. Now imagine if you're baking a cake at home, that's only 350 degrees. So if lava were to cover your car, it would melt. It's hot enough to melt rock. I've been in a situation where I've had lava in my hand, like a hot potato. It's so hot.
So you must have been in there very short periods of time, otherwise this you might even burn.
Exactly. It will protect me, but not for a long time. I'll put on the suit, I'll get into the volcano, close to the lava, maybe for a few minutes to grab a sample, take some photos, and then out.
So how does a volcano work?
Well, I've got a simulation right here, and I can show you. Hit the button.
Okay.
Solar volcanoes are one of the biggest kinds. Yes, and when they have a huge eruption,
look at that.
Rocks can go flying for kilometers out of the volcano.
And look at the streaks of ash with the rocks.
Yep. Tremendous
Flying
amounts of
out.
ash that can bury cities and spread more than halfway around the world.
It's almost like an avalanche of ash.
That's exactly what it is. That's a pyroclastic flow. It is an avalanche of ash and hot gas pouring down the side of the mountain. Pompeii is a city in Italy that was completely buried by ash in 79 AD, a long time ago, and they were actually able to excavate, find the city underneath, and they actually found the shell of people that were buried by the volcano 2,000 years ago.
The shell?
By digging down, they were able to find empty spaces in the piles of ash where people used to be. They filled those holes with plaster, and when they took away all the ash, they found the shape of human beings.
Whoa.
It's really amazing to see. The power of a volcano, it's like a gigantic bomb going off.
If the city was at the bottom of the volcano, could any people run away and escape before it came in?
Depends on the size of the volcanic eruption. A big eruption, like the one that we just simulated here, you would have pretty much no chance of running.
How does that suit protect you then?
Well, let me show you. Come on. All right, I'm gonna show you exactly how this suit protects me from a volcano's heat. I got my friend Mark here. He's gonna breathe fire on me. Stand back.
Cool. I'm not sure what they're about to do, but whatever it is, do not try it at home.
Whoa. Ready?
Whoa! Whoa, that was amazing! Woohoo! That was great! Thank you guys so much for joining us. Back to you, host Harrison.
What a coincidence! That's how my grandma bakes her cookies. Thanks, Sydney. And now it's time to go to the question that started this investigation.
What will happen if someone cracks the earth?
The big answer is nothing new. The Earth already is cracked, and it's still cracking and shifting as we speak.
Along with that, we get new mountains, new islands, and we have to live with occasional earthquakes and volcanoes.
Which unfortunately we can't predict. But here's something we can predict. At the beginning of the show, I promised you a huge eruption, and here it is. So here I am back at my school's loading dock, which they've let me use for this demonstration, and Professor Sticks has come to help me out.
Yeah, Harrison, we're gonna make an explosive eruption. We're gonna shake up these cans and we're gonna simulate a volcanic eruption on three. Ready?
Okay,
one, two, three. All right, not bad.
So that was fun, but it wasn't that explosive finish that you've been waiting for. Right, Professor?
Yeah, I think we can do better.
Yeah.
Wait, what's the first thing you do when a volcano erupts?
Run?
As fast as you can.
Okay. Ready? 1, 2, 3. See you next time for more Finding Stuff Out!
Welcome to Finding Stuff Out. I'm on a trampoline with a popsicle and earmuffs because of some questions I got. Starting with this one. Sorry, it's just a bit tricky to get my remote without dropping my popsicle. Is there anything left to discover or invent? I don't know, but by the end of the show, I'll find out. Meanwhile, I wish there was an invention that could keep me from dropping my popsicle while I click my remote, because I have another question. Not again.
You know, I'd like to invent something one day. Do kids invent things?
Yes, kids do invent things. And that's why I'm jumping on a trampoline with earmuffs and popsicles. Because all three of those things were invented by kids. I found out that 15-year-old Chester Greenwood invented earmuffs in 1870 because his ears got cold when he went skating. Frank Epperson was only 11 when he invented popsicles. George Nissen was a teenager when he invented the trampoline, which he later taught a kangaroo to jump on with him. Jumping with a kangaroo wasn't an invention or a discovery, but it was pretty cool. And kids invented other amazing things too. Like glow-in-the-dark paper, braille that allows blind people to read, an invention that would later become a TV, or a flashlight that turns body heat into light. No batteries required. Okay, maybe I can invent a hands-free way to hold my popsicle on the trampoline. Maybe not. But kids do invent stuff all the time, and we're going to meet some of them right now and see what their inventions are. This is a huge science fair. 500 kids who love science are here to show off their ideas, experiments, and inventions. And I'm gonna meet some of them right now. Hi, Dylan. So what's your invention?
My project's about generating power from the sun without using solar panels. The way I'm doing this is using mirrors. So the sun is hitting these mirrors, reflecting back, and creating a superheated spot.
That's hot.
My dish needs to be facing the sun at all times. So I developed my own active tracking software.
Cool, but this needs to be bigger, right?
Yes, my plan is to make a very large version. I have a 3-meter dish and a 14-foot arch on top of my roof, and hopefully heat my hot water tank, my house, and power my lights.
Wow, free energy.
Exactly, free energy. This is my passion, and it feels amazing.
It is amazing. Good luck. Our next inventor made something that doesn't use the sun, but it definitely is out of this world. Hi.
Hi, Zoe. My name is Eunyoung Kim, and I invented a glove that's for astronauts to use on Mars.
Whoa.
Since Mars is so dusty, my glove helps astronauts pick up their tools because basically they're blind on Mars. So there's sensors built into this glove, and when the sensors get close to an object, it sends signals to this small computer that makes the glove vibrate.
Do you think NASA will want to use your invention?
Yes, I think it's a good opportunity for NASA to use this glove when they go to Mars.
Woohoo! Let's hope they do. Now here's an invention that you definitely don't need gloves to use. Hi.
My name is Deho Daniel Sky. I'm from a First Nations community called Gahnawage, and my project is the door pedal. The door pedal allows you to open up your door using your foot instead of your hands.
Cool, but who uses it?
I went to my local hospital and I allowed a nurse to try it out because there's lots of germs in the hospital. She said it was very sanitary because she doesn't have to touch the door handle anymore. And also at my grandmother's convenience store. So now when she's bringing big, heavy things into her store, she can now just open it with her foot. This should open doors for me.
Talk about using your head and your feet. And here's Tamid. He invented a wheel that can adjust to any road condition.
You can see that the wheel is a complete circle right now. You can see it changes into something very, very spiky. I spent many weeks, months on the computer screen trying to get my parts to fit together, and when it finally did, when the wheel was finally able to turn and also change shape, it felt great. Woo! This really works well in sand, in snow, in mud, but then when you come back to a highway, you're able to press the button again and get it back to a circle.
Well, that's like reinventing the wheel. Thanks. Now here are two people who also took a really old invention and made it into something new and amazing. Hi.
Jenna
and Elijah are Inuit and live in the far north in Saluit, Nunavut.
That's Hullik Inuit oil lamp.
They worked out a way to use the heat of a traditional oil lamp and make electricity to charge a cell phone.
Heat from Hullik, it make electricity, so you can charge when you're camping.
So you never run out of power. Cool. That's a lot of inventions. But what about discoveries? Here's a question from Michael.
What is the difference between a discovery and an invention?
Yeah. What's the difference? That's what I asked some of my friends.
Ask a friend.
An invention is something that you make, and a discovery is when you find something, but it's already made by nature. A discovery is when you find something new, and an invention is when you make something new.
Well, I checked, and I found out you guys are right. Now,
Speaking of discoveries, here's a question from Daniel. What does eureka mean?
well, Daniel, when I was trying to find out what eureka means, I found this great story.
So I made this animation.
Archimedes was an ancient Greek mathematician, philosopher, engineer, astronomer, and inventor. Fortunately, despite being very busy, rumor has it he still took a bath regularly. The story is he discovered the principle of displacement when he noticed how the water level rose when he lowered his body into it. When he realized his discovery, he shouted out, "Eureka!" which is the ancient Greek word for "I have found it." Archimedes also discovered that stuff that's less dense than water, like gases for instance, float to the surface instead of sinking to the bottom. We don't know how he discovered that, but you never know. Eureka!
Speaking of eureka, I had an idea to put bouncy springs on my popsicle, so while I'm on the trampoline, it can bounce along with me.
Oh no.
If I can't invent a way, maybe I'll discover one eventually. I have discovered that kids have discovered a lot of cool things.
When she was 10, Catherine Gray discovered a supernova. That's an exploded star. And Catherine is a bit of a star herself because she's the youngest person to ever discover a supernova. 15-year-old Tom Wagg discovered his own planet. And 15-year-old Willem Gattery may have discovered a lost Mayan city by using star maps. And lots of kids have discovered ancient fossils.
Hey, cool! A dinosaur fossil. Here's a question from Mateus.
Who found the first fossils of a dinosaur?
Flat Earth Corner! I wish I could find something really valuable down here, like gold. Hey, that's odd. There's something there. Forsooth, I found the bones of a dragon. Hey, I wonder if these bones would taste good in soup. I could be the first kid to invent dragon soup. People who found the first dinosaur fossils thought they were the bones of dragons.
I guess dinosaurs do sort of look like dragons, but it took a while for people to realize what they'd found. And it took a while for the grand prize winner of the science fair to discover a treatment that might help some people feel better.
Hi Zoe, my name is Melissa, and I was able to make a discovery in many patients that had a type of cancer, lymphoma, so it's a cancer of the blood cells. They're usually treated with something called chemotherapy. Then the cancer patient usually starts to feel really bad because that treatment kills your good and bad cells all at the same time. I wanted to develop a new method to help cancer patients so that they wouldn't become so weak.
Wow. What inspired you to do that?
I have an uncle who has cancer. I also have many friends who are related to other people who also have cancer. So it affects many people, and I wanted to do something that would help a lot of people. I still have a lot more research to do, and hopefully one day be able to really make this treatment available for everybody.
Good luck. Thanks, Melissa.
Now I'm going to meet some inventors who also had a very personal reason for making their inventions. This is Samantha Guay and Tegan Kit. They also wanted to invent something that would help people. Wow, this isn't like any other boot I've ever seen before.
We were inspired to invent it by one of our friends who is almost always getting hurt. She has a lot of accidents.
She fell off a trampoline once.
She fell off her bike.
And a fence. So I'm guessing this boot doesn't prevent injuries. What does it do?
Our friend was always getting cast, and when she was going out in the rain, it would always get wet, so we wanted to make a boot so she didn't have to get her cast wet.
And the whole cast can fit inside, and it just does up.
To try it out, I put on some extra heavy socks so it'd be like I have a cast.
Now you can put the boot on and see how it works.
Cool, no laces.
How does it feel?
It's comfy. I could see how this could hold a cast. Ta-da!
In the beginning, our invention was going to be on a shoe, but the shape wasn't right. So we picked a boot.
And when we were making the boot, some of the glue wasn't strong enough, so we had to get new glue. And
first, when we were doing it, we used magnets like this on one side and washers on the other side, but it wasn't strong enough. So
we
used
decided to use
magnets on both sides.
Okay, now I'm going to put your boot to the test. So my foot won't get soaked?
Not a chance.
Definitely not.
Okay, I'm gonna go a little bit more daring. Hey, my foot isn't wet. That's awesome.
It's actually meant for puddles, but it works in the shallow end.
What's next for you inventors?
We would like to add some reflectors to the boot to make it more safe at night.
And add some cool designs to make it more fashionable. And we also have come up with a logo.
Puddle jumpers. Awesome. So Samantha and Tegan were inspired by trying to keep things dry. Now here's an invention created by someone who wanted to make sure people could get wet when they need to.
Rachel Brower won medals at 2 science fairs, including a gold medal for her very watery invention.
Hi, Rachel.
Hi, Zoe.
So what did you invent?
So this is a water pasteurization system for third world countries. It removes the bacteria and impurities from water, making it safe to drink.
What inspired you to make this?
So a couple years ago when I was 11, my family went hiking in New Hampshire. We saw the lakes and the rivers, but then we saw the contaminated do not drink signs. And at the same time, I was reading the I'm Malala book. And in this book, many women and girls are dying from the cholera outbreak. So I put the two things together and I decided I wanted to make a difference.
Cool, so how does it work?
So first the water is pumped from a water hole or lake, and then it runs through this basic cotton and charcoal filter system. Once it runs through this system, the 2-liter bottles are filled up, and then you would remove them from the system.
What did you find difficult?
So though the system removes the impurities, I found that bacteria is also found in water. That's when I designed this novel color-changing wax indicator. So once your 2-liter bottles are removed from the system, you'd place this inside and then place your bottles on a piece of corrugated tin roof. The sun will heat the water to 40 degrees Celsius, and this blue wax will change from dark blue to light pink, indicating that the water's heating up. Then once that water reaches 60 degrees Celsius, this will melt and run into the second vial, indicating that the water is safe to drink.
Wow, that's awesome. So what's next?
And this summer, my system will be tested in Kenya and Pakistan.
Do you have a message for kids who'd like to invent stuff?
Find something you're passionate about, and just because you're a kid doesn't mean that you can't make a difference.
Thanks for being on my show and showing us your invention. Now here's a question from Yasmina.
How many discoveries and inventions are there in this world?
How many inventions and discoveries are there? Let's see. Electricity, fire, air conditioning, toilet paper, the printing press, vaccines, getting warm, refrigeration to keep heads from getting warm, eyeglasses, internet, jet engines, airplanes, helicopters, rockets, compasses, calendars, cars, radios, cranium getting hot, brain starting to overload, pasteurization, telephones, boats, motors, cars, radio, cranium getting hot, DVDs, drones, boot chains, synapses firing like a laser. Oh no! Ah!
You're gonna make my head explode!
The truth is, nobody really knows how many inventions and discoveries there are, because there have been so many throughout history. And this gives me an idea for a song. Inventions and discoveries, doing something new. They help us do things that we wanna do, like dreaming up a robot to help us clean our room, create a kind of rocket to take us to the moon. From the sun, non-polluting cars, gloves that help you find your tools on Mars. Inventing and discovery, it's doing something new. Inventing and discovering will open doors for you. Inventing and discovering will open doors for you. Inventing and discovering will open doors for you.
My Great Challenge! winners are Angeli and Logan versus Stefano and Sasha.
Yeah.
I'm gonna show you some weird inventions, and both teams have to guess what they are.
If neither team gets the answer, you get a clue.
The team that gets the most correct answers wins. You ready?
Yeah.
Okay, you girls are gonna go first. Okay.
I think it's like for the baby to go inside. And
babies are bigger than this.
So, like the new.
We're going for hammock,
I guess.
Okay.
A hammock?
Yeah.
Sorry, girls, that's wrong. Boys, your turn.
Don't see it. Oh, nice cat.
A bag of litter for cats.
Sorry, guys, that's not it. Okay, you guys get the clue now.
Cat bed.
Yeah. You guys were right. It's a bed for cats.
Yes.
What is it?
Cheese shredder or
something shredder.
Yeah, it's like a shredder. Yeah, it comes out from here.
Yeah. Is it like a shredder?
Sorry, guys, you're wrong.
So I think it's something that you could put like a fruit or something inside.
A fruit cutter, let's say.
A cutter? Sorry, guys, that's wrong as well. So you guys now get the clue.
A juicer.
Yeah, you guys are right.
Yeah.
You put the lemon in, and you squish it, it comes out. You hear that?
Yeah, I hear it.
Let's see how much juice it made.
You spilled some.
What is it?
Has to be like a decoration for something.
I don't think so.
It's something that we
used to clean a toilet or something. A drain.
Sorry, girls, that's wrong. Okay, you guys go.
But could it be a decoration? Because this could be the hair. This is another McFly. No, why would it be a doll? But can't you see? Does this look like a doll's hair?
Eyes. Okay, guys, I need an answer.
A decoration.
Decoration? Sorry, guys, that's also wrong. Okay, now you guys get the clue.
Oh, it's a potato smasher?
You guys are right. When it's baked, you mash it.
Oh, I know what it is. It's like one of these old-fashioned bells. Hold on.
I don't think it's a bell.
Yes,
there's no like ball inside.
You put the ball inside.
I need a final answer.
What did I say?
A bell?
Sorry, guys. That's wrong.
Sorry, turn. Is it to take out a core of an apple?
Nope. You guys get the clue.
Maybe a lighter?
No, impossible because there's no fire thingamajig.
Yeah, but you could put something in.
A lighter for candles?
Sorry, girls, it's not it.
Oh, maybe not. Is it to take out the light?
Yeah, you guys are right.
Yes.
You use this to put out a candle without burning your fingers.
All right.
Okay, both teams have 2 points.
So this is the tiebreaker. What is it?
A measuring magnet?
A measuring magnet? Sorry, girls, that isn't it.
There's circles on it. Could
it be a tracer?
Is it a tracer?
Sorry, guys, that's not a tracer. So you guys now get the clue.
Oh my! It's the whole. Is it like to measure the pasta?
You guys are right. It wins. Yes. What you do is you put it in, and that's how you measure it for 3 people.
That's cool. I need that at home.
Well, thanks for being on my show and helping me find stuff out. Now, time to answer the question that inspired my show today.
Is there anything left to discover or invent? The big answer is... Well, Anthony, to answer your question, I've decided to ask someone who's gone all the way to space to discover things. Astronaut Chris Hadfield. Chris, thanks for being on my show. So, do you have an answer to Anthony's question? Is there anything left to invent or discover?
Zoe, we have no idea what we're doing. We are just getting started. We don't know what 94% of the universe is even made of. We are just infants. There are so many problems that we need to solve, and we're counting on scientists and engineers and bright young people like you and like people right across the country and around the world to solve those problems. So there's a whole world of things to discover and learn from and improve the quality of life with.
Thanks, Chris. Well, that's my show for today. By the way, notice anything different? I finally invented a popsicle holder that lets me use my remote and take my earmuffs off. See you next time for more Finding Stuff Out.
It's so cold. How am I going to get through winter? It's freezing outside.
Whoops, you caught me there.
I'll admit it. It's not actually winter yet, but I'm planning ahead.
I know that some birds fly south to get out of the cold. It's called migration. And I wondered why we don't do the same thing.
It seems like such a good idea. Gabriella had the same question I did.
Why do some animals migrate and some don't?
I don't know, Gabriella, but I promise to have the answer by the end of the show. Jacob has another great question.
What kind of animals migrate?
At first, I thought only birds migrated, but I checked and found out all kinds of other animals migrate, like reindeer, whales, salmon, and even penguins.
But they're also different. I don't know yet why those specific animals migrate and others don't.
But here's what I did find out.
Some animals don't have to migrate because they're adapted to winter. For example, snowshoe rabbits' fur turns white in the winter and helps them blend in with the snow to protect them from predators. While in the summer and fall, their coats keep them camouflaged. And some animals like bats and bears don't need to migrate either. They just say, nah, I just want to sleep. So they hibernate for the entire winter.
So, some animals migrate, some adapt, some hibernate. I feel a song coming on.
Should I stay or should I go? There's gonna be a lot of snow. I need seeds and bugs to eat, but the snow will freeze my trees. I don't have a furry coat or a warm barn like a goat. I think I'm getting a sore throat. Should I go or should I stay? Cold is coming any day. I'm not sleepy like a bear. Instead of here, I should go there. Winter's gonna be a battle, so I think I'll just skedaddle. Yeah, I think I'll just skedaddle. Bye!
Migrate, hibernate, or adapt to winter. What about you? I asked some of my friends what they think.
Ask a friend. Hibernate because I like sleeping in, so I think that I would like that.
I would rather migrate to a tropical island, relax.
I'll migrate because I like going new places.
Adapt and have white fur.
I would rather adapt because I like the snow and I wouldn't have to sleep. I would like to be in a tropical island, but I would like to play in the snow.
Hibernate.
Because I could be warm in a cave.
Me? I would definitely migrate. Sun, beach, no snow. But I'd want to stay there all the time. Which reminds me of a great question I got from Ruby.
Once an animal migrates, why don't they just stay there?
Good question, Ruby. Which is why I decided to call a serious migration expert, marine biologist Marla Barker. Hi, Marla.
How are ya?
Good, how are you?
Well, yep, we're ready to go. Are you ready?
Yeah.
Hold on, Zoe.
All right.
Off we go.
Marla is taking me out to see some gray whales. Whoa! They're one of the animals that migrate, and if we're lucky, we'll get to see them here in one of their favorite spots. They come here every year.
Okay, Zoe, if you keep scanning too, we'll be able to figure out when they're about to surface again.
Okay.
Hey, here.
Look it.
That's the mom and the calf.
Look it. That's so cool.
That's the baby, just beside her. That calf will never go far from its mom. Here it comes. You can see the little white head. There.
Whoa!
This baby was born in Mexico over the winter.
That's crazy. Does it stay by its mom the whole time?
It will, because it needs to learn everything it needs to know about where to find food, how to migrate from Mexico to here, and maybe even up Alaska. It might even go all the way up to the Arctic with its mom.
That's amazing.
And then how to stay away from killer whales and how to remember how to come back here on its own because pretty soon it's gonna separate from its mom. And the next time it needs to make its migration, it will be on its own.
Why do they migrate to Mexico?
Well, the water's warmer there. That's for you wouldn't have to wear this crazy suit if you were in Mexico. A lot of whales make really extravagant migrations, movements between warm water and cold water so that they can feed where the water's cold, like here. This is like the cold water supermarket. And up off Alaska and to the Arctic where the water's even colder and there's more nutrients in the water, whales will migrate to places like that. But they'll go to Mexico because when the babies are born, they don't have a lot of fat. You need to nurse off your mother's milk, which is like 53% milk fat. If it can spend a few weeks nursing and getting a nice layer of blubber, then it's like wearing a wetsuit. It can migrate to colder water.
That's so cool.
It's great having you, Zoe, and I'm so happy I could show you your first gray whales ever.
Me too.
Here's a question from Maddie.
Why do fish swim up the stream to migrate?
Yeah, I've always wondered why salmon do that.
It seems like poor planning.
Time to go home. Uh-oh.
I found out that salmon are just going back home to have their babies. They have to go back upstream to do that. But how do they know? It's still a big mystery. There are lots of theories. Some scientists think that salmon use their sense of smell. The Earth is actually a huge magnet. So other scientists think that salmon can tell the right way to go because their bodies sense the pull of the Earth's magnetic field.
Cowabunga!
But what about birds? Here's a question.
How do migrating birds know where to go when they've never been there?
Walk straight, turn left, walk 3 paces, make a U-turn, take 2 steps and turn to your right. Take 2 small steps and you have arrived. My phone has a GPS program that tells me where to go. Scientists think birds may have something similar, and they can use the sun and stars to help them find their way. Here's how stars look in North America. And here's how they look in South America. When birds are young, they learn what the stars look like on their trip south. So on the way back, all they have to do is look up and they know where they're going. Wow, birds are smart. Speaking of smart, here's a smart question from EPEC.
Can birds fly super high over the Himalayas?
Flat Earth Corner! Can birds fly over the Himalayas? The highest mountain range in the world? Of course. That's nothing for birds. Do you know why? Because they're flying to the moon. That's where they go in winter. What other explanation could there possibly be? I've never seen where they go, and neither have any of my friends. So, obviously, they go to outer space.
So old Charles was definitely not right about birds going to the moon. But he was right about birds being able to fly over the Himalayas, which are almost 9,000 meters high. They're as high as some airplanes fly. There's at least one bird that can do it. It's the bar-headed goose, and it can fly over the Himalayas in only 8 hours. Me? I can't even walk to the next town in 8 hours. Next question.
Do bugs migrate?
Great question, Lola. I never even thought of insects migrating. But I looked it up, and there's one type that goes pretty far each year. And that's the monarch butterfly. They go all the way from Canada down to Mexico, and they travel almost 5,000 kilometers. But it looks like they need help. About 9 out of 10 monarch butterflies have disappeared because their home ranges are getting smaller. Their food is being wiped out by too much spraying of herbicides. Good thing there's a way we can help. My friends Ailianne and Jonathan have one solution.
The experiment!
is beautiful. So many nice flowers. Yeah, it's a butterfly garden, Zoe. Butterflies really like these flowers. It helps them. How do you make a garden for monarch butterflies? You plant these milkweed seeds. These are the only flowers that monarch butterflies actually lay their eggs on, and the only flowers that their caterpillars eat from. Monarchs really need milkweed to survive. Without them, they could die. Yay! Yeah, and you can also buy milkweed plants at the store and plant them, of course. It's better if you have a whole lot. Hey, what's with the rocks? Butterflies need to be warm to fly. The sun warms up the rocks, so that way butterflies like to warm up on them. And they also need water. Wow, talk about a monarch paradise. It will help them migrate. But where are they? Be patient, they'll come. I have an idea. Good one. You really got us this time. Bye-bye, butterflies. I wonder how far other animals go. Thankfully, Eleni is on the same wavelength as I am.
What is the furthest distance a bird has ever traveled, and how long did it take?
Now we know that fish, birds, and insects all can travel really far when they migrate. But let's see who can go the longest distance. It's not a fish. It's not an insect. Woohoo! And the winner is a bird called the Arctic tern. The Arctic tern flies over 71,000 kilometers every year. It goes all the way from the North Pole to the South Pole and back again. But how do we know that? Here's a question from Haria.
How do we track animals that migrate?
She knows about how birds move because birds have a long distance to prove. It's Barbara Fry. Hi, Barbara.
Hi, Zoe. This is for you.
Is it for my hair?
Well, I sometimes call it bird bling, but it's actually not a fashion accessory. It's a bird band, and it's how we track migrating birds.
Great, now you can track me.
Good one.
Haria wants to know how you track animals that migrate.
Well, there's lots of different ways to track different animals. My specialty is birds. So first, to track them, you have to catch them. So I catch them using these mist nets. Now, mist nets, we hang up and they look like thin volleyball nets, but they have special pockets that birds can fly in. We put them up early in the morning, even before the sun comes up, and we catch the birds that migrate through.
Does it hurt the birds?
No, we use these carefully designed nets, and we also have training so we know how to take them out of the nets carefully. After we catch the birds, we put them in cotton bags to keep them calm and warm when we bring them over to be banded at the banding station. Now, the first thing I have to do when I catch a bird is I need to know what species it is. So I look in my bird books and I look at the color of the plumage and their pattern, even the shape of their bill, the color of their eyes to give me clues so I know what species it is. Then when I know what species it is, I know what band size to put on because there's all different sizes for different sized birds. I put them on with special banding pliers around their leg. So it's like wearing a bracelet or a wristwatch.
Does it bother the birds?
No, they're specially made and they're lightweight aluminum, so they're very light to carry. So after that, I might measure its wing to see how big it is. I might even blow on its chest and its belly to look at the amount of fat that it has put on, because before they migrate, birds have to eat a lot of food and gain a lot of fat so they can do that migration.
Yeah.
And then the last thing I'll do is I'll usually weigh it, and then off the bird goes.
So how do you know where it goes?
Well, there's other people like me working all over the world putting up mist nets. So when I band a bird, say in Canada, somebody down in Colombia in South America might catch it again, read that band, and know exactly where that bird came from.
Cool.
Recently, technology has allowed us a new way to track birds using these high-frequency radio tags, or nanotransmitters. Now, rather than having a unique number, they have a unique signal that they emit. So they just have to pass by these big towers with antenna on them, or sometimes I walk around and try to find birds with a handheld antenna. And it's like you going to your radio station and turning the dial and hearing all the different songs. I can find all the different birds I've tagged.
Cool. So what's your favorite bird?
Oh, Zoe, that's a really hard question because I've been birding since I was 5 years old, much younger than you. But I have to say, it's a bird called the bobolink. Now, the bobolink isn't the prettiest bird to look at, but it has the most beautiful, bubbly, happy song that always makes me smile. It's also special to me because it's one of the fastest disappearing or declining birds in Canada. And that's really worrisome because birds have a unique role, just like every other species. Birds eat seeds and insects. They make holes in trees for other creatures to live in. And the more species we have, or the more biodiversity, the healthier the planet is and the longer and happier life you and I can live. That's one of the reasons I do bird banding, is because that way we can learn about where birds go, where they stop, and if birds are declining or increasing, and all this other information we can learn about them.
Wow, thanks for protecting the birds.
Well, it's a lot of fun and my privilege.
Do try this at home.
I found out birds can get confused by windows and fly into them. Ow! Sorry, little bird. But here's a secret weapon to help them never hit a window again. A yellow highlighter. I'm doing it. I'm doing it. Birds can see things we don't, and they can see the highlighter ink very well, so they can avoid window pain. Get it? Window pain?
Next question.
What challenges do animals face when they're migrating?
There's lots of different challenges they face, like having to go a really long distance and having to go without food. But one bird has a very special challenge. Some emperor penguins travel nearly 300 kilometers to their nesting grounds. There, the female lays a single egg and hands it over to the male. The egg can't touch the ground because the chick inside would freeze. The female then goes fishing to feed her family. She'll be gone for 2 months. The male and the chick that has hatched wait for her without food in icy temperatures. Speaking of challenge, it's time for...
My Great Challenge!
I'm going to be a challenger, and today we're going to be emperor penguins. Mac and Adriano, you guys are going to be the daddy penguins. Whammy and I are going to be the mommy penguins. We have to pass our eggs to the daddy penguins, and the daddy penguins are going to keep them warm as we go fish to feed our babies. First team to feed their babies 3 fish wins. On your marks, get set, go! Mommy penguins first have to pass their egg to the daddies without having them touch the ice. Darn it. If they drop the egg, they have to start again.
We're gonna break these eggs.
Okay, we gotta be careful. Ready? Go. Did you get it?
Almost.
Get it?
Nope.
Get it? Yes! Okay, go, go, go! Don't drop it, remember, don't drop it. Daddies have to walk a full circle with their egg and their babies will hatch. Don't drop it. Done. Okay, both teams are done.
I'll take this off. Put them on quick. Okay, go, 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 go.
Okay. Go. Now, mommy penguins have to catch 3 fish and bring them back to feed their baby.
Oh no, she got it. Oh no.
Come on, quick! Super quick! Oh no, I can't find a fish. Team Antarctica, you guys win. Would you guys like to be penguins? Well, thanks for helping me find stuff out. Wow, that was great. Speaking of great, here's a great question from Andrew.
Can humans migrate?
I checked, and the answer is yes. People have always moved from one place to another for all kinds of reasons. It can be to escape poverty, conflicts and war, natural disasters, climate change, or to find work. But basically, immigrants and refugees migrate in hopes of finding a better life and for a lot of the same reasons other creatures migrate. Animals and people are really looking for the same thing. a safe place with food and shelter. And I think that means we're ready for a big answer.
Why do some animals migrate and some don't?
Well, Gabriella, the big answer is... food and warmth. Some animals migrate because they have to get food or stay warm. Some animals don't migrate because they're adapted to where they live. And other animals just sleep the whole winter away. But I don't want to sleep all winter long. I can adapt by putting lots of layers on to keep warm. But still, maybe next winter I can go down south with the butterflies. At least I know I'll be warm if I follow them. See you next time for more Finding Stuff Out. Woohoo! I'm going with you, butterfly!